Okay, let's have a look at kinetic molecular theory and how it applies to gases. So we have this model so that we can better understand how gases behave. Now it's worth bearing in mind that it's only a model and it doesn't apply to every situation. So we've got four main points that describe our gases or are used to help describe the properties that we observe in those gases. Firstly, a gas is a collection of particles, whether they be molecules, atoms, or a mixture of those two to form our particles, and those particles are in constant motion. And we also say that the motion is by necessity in a straight line. Secondly, the particles of gas do not interact. In other words, there's no repulsion or attraction between those particles. Instead, they have elastic collisions, whether those collisions be with gas particles themselves or the container or objects within the gas. Thirdly, we say that there's a lot of space between the particles relative to the size of those particles. So in other words, because the atoms or molecules are very small, the space around them is very large and they're free to move. Finally, we say that the speed of the particles increases with temperature, or we can also say that the average kinetic energy of those particles is directly proportional to the temperature of the gas. In other words, as the temperature increases, the average kinetic energy of those particles must also increase. And in a similar way, if we reduce the temperature, the energy of the particles goes down as well. So these four observations can help us with our observations of the properties of gases. And we make these, or we predict these properties based on this theory. So first of all, we can say that gases are compressible, and we can observe that in nature. Gases are compressible. Gases also assume the shape and volume of their container. So if we move the gas to a different container, the gas will assume the shape of the new container. We can also say that gases have very low densities compared to liquids and solids. Now there are obviously different densities within those gases, and we find some quite dense gases. Carbon dioxide is reasonably dense. On the other hand, we have some very low density gases as well. Now we can add one further point as well, and that's that gases collide with their container walls, creating what we call pressure. So, simplified diagram here, if we have a balloon and we put particles of gas inside it, such as us breathing into the balloon will expand because we've increased the number of particles within that balloon. Therefore, they increase the pressure within that balloon as well.